This is Euclid Book 7, proposition number 2. And before we get into this, I'm going to show you this little illustration. Pause the video, write all this stuff down. Okay? Now then, this is going to be about Euclid's algorithm. Do you remember me talking about that in the previous video? We're going to talk about that further today. All right. Let me read this to you. Given two numbers not prime to one another. We're going to actually present this entire proof in two separate videos. The reason for that is that Euclid has 3 cases. The first 2 we can present immediately. The third one we're going to have to present in greater detail in the next video. So given two numbers not prime to one another, this time we're going to use the numbers 4 and 12. We're going to say that AB equals 12 and CD equals 4. To find their greatest common measure, let AB and CD be the two given numbers not prime to one another. Okay? And 4 and 12 are not prime to one another. Thus it is required to find the greatest common measure of AB and CD. Okay. Let's continue. If now CD measures AB, well, CD, what you'll do is you'll have 12 subtract 4, you'll get 8. 8 subtract 4, you get 4. 4 subtract 4, you get nothing. So obviously 4 can measure 12. CD measures AB, 4 measures 12. And it also measures itself. CD measures CD. 4 minus 4 is nothing. CD is a common measure of CD and AB. And it is manifest that it is also the greatest, for no greater number than CD will measure CD. Okay? But if CD does not measure AB, this is where we bring up CD being 14 and AB being 32. Okay? 14 does not perfectly measure 32. Then the less of the numbers AB and CD being continually subtracted from the greater, some number will be left which will measure the one before it. For a unit will not be left. Otherwise, AB, CD will be prime to one another, as in Euclid Book 7, proposition number 1, which is contrary to the hypothesis. Therefore, some number will be left which will measure the one before it. Now let CD, 14, measuring BE. Alright, now we're going to measure BE. And the first thing we're going to do is we're going to subtract 14 from 32. Well, 32 minus 10 is 22. 22 minus 4 is 18. Okay? Now, if we were to subtract 14 from 18, we get 4. Okay. Now let CD measuring BE leave EA less than itself. Well, EA in this case is going to be 4. Let EA measuring DF. Alright. We've established that we're going to use 4 to measure 14. Well, 4 times 3 is 12. So what you're going to do is 14 minus 4 is 10. 10 minus 4 is 6. And 6 minus 4 is 2. Okay? Let EA measuring DF leave FC less than itself. Well, what is CF? It's 2. Alright. And let CF measure AE. Well, 4 minus 2 is 2, and 2 minus 2 is 0. So CF successfully measures AB, or AE. Since then, CF measures AE, which we already proved, and AE measures DF, okay, therefore CF will also measure DF. Well, we got CF, which is 2, and DF, which is 12. 12 minus 2 is what? 10. 10 minus 2 is what? 8. 8 minus 2 is what? 6. 6 minus 2 is what? 4. 4 minus 2 is what? 2. And 2 minus 2 is what? 0. Okay. Alright, CF will measure itself. CF, which is 2, minus CF, which is 2, leaves nothing. Therefore, it will also measure the whole CD. Well, CD is 14, and of course we can go through the process. 14 minus 2 is 12, and 12 minus 2 is 10, and 10 minus 2 is 8, and so on and so forth until we got to nothing. But CD measures BE. Well, what's BE? Well, BE is 28. And if you wanted to start that way, 28 minus 14 is another 14, and 14 minus 14 is 0. So it does. Therefore, CF also measures BE. Well, what's CF? CF is 2. BE is, of course, 28. 28 minus 2 is 26. 26 minus 2 is 24. 24 minus 2 is 20. Or 22, sorry. And 22 minus 2 is 20, and so on and so forth. We go all the way down the line until it comes to 0. But CF also measures EA. Well, 4 minus 2 is 2, and 2 minus 2 is 0. Therefore, it will measure the whole BA. Well, what is BA? Well, AB, of course, is 32. And so CF will measure 32. But it also measures CD. Therefore, CF measures AB and CD, which 2 will measure both 32 and 14. Therefore, CF is a common measure of AB and CD. And that's the first part of Euclid Book 7, proposition number 2. Now, we've already established that CF is a common measure of both AB and CD. Now, all we're left to do is to prove that CF is the only common measure between AB and CD. We will do that in the next video. Stay tuned.